We're going to be talking about Newton's second law. We've been talking, all of our previous work has been on Newton's first law or third law, in which we had balanced forces and there was no acceleration. Well, now we're going to talk about what happens when there are unbalanced forces and objects accelerate. Acceleration means that objects change speed, so the delta V is no longer zero. Remember that from Newton's law of motion that we talked about quite a while ago at the beginning of Unit 4, that when delta V was equal to zero, that meant there was no acceleration, and it gave us that net force was also equal to zero, and we worked through a lot of questions and a lot of problems where net force was always equal to zero. For Newton's second law, the objects accelerate, so they're speeding up or they're slowing down. If an object is moving, it gets faster, or it gets slower, or it stops. If it's stopped and not moving, it begins to move. So acceleration means that somehow the motion is changing. And so delta V will not be equal to zero in this equation. Recall from kinematics that acceleration was defined as the change of speed divided by time, which suggests that up in this equation, if I divide both sides by time, then time would cancel out here and here, and change in velocity divided by time is what acceleration is, and so we get what we typically think of as Newton's second law of motion. Now, this looks an awful lot like what we've already been doing. Okay, so this Newton's second law isn't a lot of new material. I mean, there's some new parts, but there's not a lot of new material. It's very much what we were already doing. Okay. So we're going to be drawing the force diagrams. Okay, we're going to be doing vectors and resolving vectors into their components. That's the fx and fy. We're going to decide what's positive and what's negative. We're going to write two equations, one for net force in the x direction equals m times a, and one for net force in the y direction equals m times a. Typically, one of those two directions, the acceleration is going to be zero, and so we're back to what we had in the previous unit, where net force was equal to zero. From there, you plug in numbers, you solve, you substitute, you see what you know. So a couple of examples. In this example, we've got an object. Let's label this one R, and let's label this one S. And let's say that R equals 50 newtons, and S equals 100 newtons. What is the net force? I don't have any x direction to worry about. Everything here is vertical, so that's just the y direction. So the net force in the y direction has to have some value. I don't know mass or acceleration, so I can't multiply to get the answer. But we can remember that net force, this idea of net force means to take all the forces and add them up, to combine them. So looking at these two forces, I see that one is up and one is down. Direction matters. So I would label this one as positive 50 and this one as negative 100. And when you add those two things together, net force would equal positive 50 newtons minus 100 newtons. And so the net force would equal negative 50 newtons, which would mean that the net force is 50 newtons pointing downwards. So 50 newtons down. It's what's left over. So net force is basically the remainder after you combine all the other forces that are acting on an object. Okay. Typically in the homework questions, you might know something like S equals 500 newtons, and R is unknown, but the net force is equal to, let's say, 150 newtons upwards. Okay? So you might know that sort of information. The question is, what is the value of the missing force? And so to solve that, we approach the problem in exactly the same way. Okay. R would be there, would be positive, S would be negative, again because it's pointing down. The net force is given as pointing upwards, so I would label it as positive also. Net force would equal R minus 500 newtons. That has to equal positive 150 newtons. Add 500 to both sides, and I get that R equals 650 newtons. So it tells me that R, by the time I'm done canceling out this 500, I still have to have 150 left over. The remainder, after canceling out or after combining those two forces, one up and one down, is that the remainder is 150 pointing upwards. So I have to have 150 more going up than going down. All right? Well, what if we have forces I've run out of letters, so let's call this one V. Okay? So we've got all these different forces acting on this object. Let's just say that this is 50 newtons. This is 75 newtons. Q is 100 newtons. V is 150 newtons. And J is 250 newtons. Okay, the question might be, what is the net force? And or what is the acceleration? So I first of all would look at this and say, well, the net force in the x direction is going to be, labeling positive and negative, 100 plus 150 minus 250, so that would be 0. If the net force is equal to 0, I know that it's not accelerating. Okay, so side to side, it's not moving. Or if it was moving side to side, it stays moving. Okay, so no change is happening. In the y direction, net force y is going to equal, looks like positive 50 going up and negative 75 going down. So in the y direction, my net force is negative 25 newtons, meaning I have 25 more newtons pointing downwards and upwards in this diagram. Now that I know that net force is negative 25, I would be set up to be able to find acceleration. I don't know enough information to find acceleration in this, but I'd at least have the ability to do so. Another example. Let's say I have an upward and a downward and an upward and a right and a left, and let's make this one be 50 newtons. Let's make this one here be 50 newtons. Let's make this one here be 100 newtons, and this be 200 newtons, and this be 175 newtons. Okay, so just making some numbers up, and let's declare the mass to be, let's make a nice easy number. Let's say the mass is 10 kilograms. Okay. Because Newton's second law says that net force equals mass times acceleration, I want the mass to remain in kilograms. Okay, I don't want there to be any change of units here for the mass. It's just measured in kilograms. If I wanted force of gravity, that I would change and measure in newtons. So in the x direction, net force in the x direction is just equal to 0 because the 50 and the 50 balance each other out exactly and cancel out. Net force in the y direction, however, will be very different. So this is up, label it positive. This is up, label it positive. This is down, label it negative. And so I get net force equals ma. So 100 plus 200 minus 175 equals 10 kilograms times A. It doesn't matter, the positive and negative on each of these is very important, which one's positive and which one's negative. It doesn't matter when I go to write the equation
right? 100, 200 minus 175. It could have been 100 minus 175 plus 200. Okay, it really doesn't matter what order I go in, but the positive and negative are very important. Simplify these numbers as much as I can. 100 plus 200 is 300, minus 175 is 125 newtons, equals 10 kilograms times A, and divide by 10, A must equal 12.5 meters per second squared. We get from that a very important relationship about the units, that if force is measured in newtons and mass is measured in kilograms and acceleration is measured in meters per second squared, that all the units are going to work out just fine. Okay? A kilogram times a meter per second squared gives us a newton of force. All right, one more example. Let's go this way and call that 75 newtons. Let's go this way and call that 100 newtons. Let's go this way and call that 150 newtons. Let's go this way and call that 200 newtons. Let's go this way and call that 50 newtons. Let's go this way and call this 150 newtons. Okay? The mass is the mass is 5 kilograms, and what is the acceleration going to be in this case? So I notice, first of all, that up and down it's balanced. So 200 up and 200 total over here going down. I don't need to worry about the y direction, side to side. I've got 175 versus 150. So my net force in the x direction will equal mass times acceleration. So negative, negative, positive. Negative 75 minus 100 plus 150 equals 5 times A. So that is negative 25 newtons, equals a negative here just signifies going to the left. It's not that it's necessarily, right, nothing special about it being negative except it means leftwards. I have more on the left side than on the right side as far as arrows are concerned, equals 5 kilograms times A. So A must equal negative 5 meters per second squared. And the negative sign in this case means that the acceleration would point to the left. So the acceleration, I say, is 5 meters per second squared leftwards, or to the left. I would drop the negative sign off of that. Last one. Let's say that the mass is 5 kilograms again. Let's say that the acceleration is 2 meters per second squared to the right. Let's put those 4 forces onto it. Let's label this one R and this one Q. And the question might be, what are the values of R and Q? All right. I notice, since it specifies that my acceleration is to the right, that R will have to be greater than 50. Since my acceleration is to the right, that would imply that Q and 75 are balanced, and so Q would equal 75 newtons. Those two would be balanced. Going the other way, net force in the x direction would have to equal m times A. Label that negative, positive, and to the right would be positive. So negative 50 plus R would equal 5 kilograms times 2 meters per second squared. So negative 50 plus R equals 10. And that would give me that R must equal 60 newtons. Okay, it's got to be 60. It's got to be bigger than 50 because it has to be enough to make it accelerate to the right. And the acceleration is 2 times 5 or 10. So I've got to have 10 more going right than I have going left. And so I get 60. Hopefully that helps explain explain some of the big ideas here of how to, kind of how to approach Newton's second law equations. There's a makeup assignment on the website and some homework assigned from class, homework 5.1.